Let's work problem number 8 on the constant acceleration worksheet number 4. And let's take a look at the problem. Here it is right here, number 8. It says, a mountain goat starts a rock slide and the rocks crash down the slope of 100 meters in 5 seconds. A, what is the acceleration of the rocks? And we're assuming constant acceleration here. How fast are the rocks going at the bottom? And C, draw velocity versus time graph. So I'm going to take this problem and reread it and do given, find, and solve. So given, well, I like to draw a little picture. We have a slope here, and we have a little goat. Here's goat horns. Actually, that's not a bad goat. All right, and starts a rock slide. So here are the rocks tumbling down. And here's a little family having a picnic down here at the bottom. All right, now, so it says a mountain goat starts a rock slide. The rocks crash down a slope of 100 meters. So we know that delta x equals 100 meters. That is, the rocks slide down 100 meters. And we know that the time it takes to get down there is 5 seconds. I think that's what it said. Yeah, 5 seconds. And, oh, we also know, we can assume, it doesn't say, but we can assume that the rocks start from rest. B naught equals 0. And what are we trying to find? A, what is the acceleration of the rocks? And B, how fast are the rocks going at the bottom? So that's the final velocity. And then C, we want a V versus T graph. Okay. Now let's solve it. Well, I want acceleration, and look what I'm given. I'm given displacement, time, and initial velocity. What am I not given and I don't need? Final velocity. I don't need that to solve part A. So which equation doesn't have final velocity in it? I look at my little chart. It's the third one. Delta x equals V naught t plus 1/2 a t squared. Okay, so I go, okay, V naught is 0, so this term goes away. And what am I trying to find? A. So I'm going to solve for A. So A is going to be equal to, well, multiply both sides by 2 delta x over t squared. That's what the algebra gives me. Now I plug in my values. So I have 2 times 100 is 200. Now what is 5 squared? Okay, 25. So what is 200 divided by 25? 8. 8 what? Meters per second squared. See how the units work? That's my answer for part A. Now for part B, what is the final velocity? Well, I don't know the acceleration. So I don't want, what if I made a mistake solving for this acceleration? I want to try to find an equation that doesn't have acceleration in it. So I'm going to use equation 2 because it doesn't have acceleration in it. Okay, this is 0. And I'm going to solve it for the final velocity. So V equals, well, that's 0, so I'm going to multiply 2 delta x and then divide that by t. So 2 times 100 meters divided by 5 seconds. So that's 200. What is 200 divided by 5? 40? 40 meters per second. And then I'm going to draw, now it's easy to draw the velocity versus time graph. It's a total of 5 seconds. 1, 2, 3, 4, 5. Okay, and the velocity, final velocity is 40, so 10, 20, 30, 40. So it starts at 0, and at 5 seconds, it's at 40, so it's just straight like that. And that's how you do problem number 8, using given, find, and solve, and the kinematic equations of motion. One final thing, you could have used, to find the final velocity, v equals v naught plus at. You could have used that. Let's see, this is 0, and then this is 8 meters per second squared times 5 seconds, right, because that's the time. And what do you get? You get 40 meters per second. Okay, which is what I got, but why did I not use this equation, even though it was a little bit easier? Because what if I made a mistake in calculating the acceleration? Do I want to carry that mistake forward? No. But doing it both ways and you get the same answer means you probably did it right. Und das ist alles.